Hello and welcome to this revision session for paper 1 for AQA A-Level Physics. So in today's lesson we're going to look at answering examination questions for AQA A-Level Physics paper 1. So if we've been successful and we've learnt in today's lesson, we should be able to answer A-Level Physics examination style questions, assess our understanding on A-Level Physics and understand what topics we need to improve upon for A-Level Physics. So how do you prepare for this revision session? Well, when completing your work in this revision session, divide your piece of paper into two sections. Make the section on the left hand side larger than the right hand side. In this section, write down your working out and answers to the questions in this revision session. Then when you're doing this, make sure you write your answers out in full sentences and show your full working out. Whilst in the right hand side, write down any pieces of information which you find useful or any hints and tips on answering the questions from this revision session. At the end of the revision session, write up these notes into a revision sheet for you to use independently. So how should you be revising for AQA A-Level Physics? Well, step 1, learn the key facts. Use your revision guides, your class workbooks, your student prep notes, your textbooks to learn the key ideas of the course. Step 2, retrieve your understanding by testing yourself. Use Caboodle, use Seneca, use the student knowledge checker to quickly test your own knowledge. Then finally, practice examination style questions. Use exam prep books, homework books, supervised study books, additional workbooks to help answer exam questions and then mark your own work. So the 3 steps of learning the key facts, then testing yourself and then practicing exam style questions are how you should be revising for AQA A-Level Physics. So let's now have a look at a few questions on particle physics. The question says, which equation shows the process of annihilation? So pause the video now, then unpause the video when you want to go through your answer. Right, in this question what we know is as follows. The answer is B. Why is the answer B? Well, annihilation is the process of a particle and antiparticle turning into energy, and this energy is released in the form of photons, and 2 photons must be released to conserve momentum. The next question says, what is the quark structure for antiprotons? So pause the video now, then unpause the video when you want to go through your answer. Right, so for this question the answer is D. This is because the antiproton has the same quarks as the proton, except these quarks are the antiquarks. So the proton has a quark structure up, up, down, so the antiproton is anti-up, anti-up, anti-down. The next question says, which row gives a particle with its quark combination and category? So pause the video now, then unpause the video when you want to go through your answer. Well, the answer for this one is going to be B. Why is this answer B? Well, a baryon has 3 quarks. A meson is a type of hadron which is made from 1 quark, 1 antiquark, and you must add the charges of the quarks together to get the right charge of the particle. So the only one which is going to be true is B. The next question says, what is the specific charge of the beryllium 2+ ion? So pause the video now, then unpause the video when you want to go through your answer. Right, the answer here is A. How do we work this out? Well, specific charge is charge divided by mass, with the charge in coulombs and the mass in kilograms. Now we know the charge is 2+, so it's 2 times by 1.6 times 10 to the minus 19, and we've got 9 protons and neutrons, so we do 9 times by the atomic mass unit, 1.67 times 10 to the minus 27, and you work that out to be 2.1 times 10 to the 7 coulombs per kilogram. The next question says, which of the following is not true? So pause the video now, then unpause the video when you want to go through your answer. Right, the answer for this one is C, because a meson is made of a quark and antiquark, and a baryon is made out of 3 quarks, and quarks can never exist in isolation. So therefore, the only one which is not true is going to be C, and you know this because if you look in the back of the equation book, there are quarks with different charges. They're not just plus a third. The next question says, when radiation is incident on a platinum surface, electrons with a maximum kinetic energy of 8.2 times 10 to the minus 19 joules are emitted. The work function of the platinum is 6.35 eV. So, what is the frequency of incident photons? So pause the video now, then unpause the video when you want to go through your answer. Right, so the answer for this one is C, because the total energy is the work function plus the maximum kinetic energy of the emitted photoelectrons. So therefore the work function we're given, but we've got to convert that into joules. So we do 6.35 times 1.6 times 10 to the minus 19, and we add that to our maximum kinetic energy. This gives us our total energy. We also know that total energy, E, is equal to hf. So therefore F is going to be equal to E over h, where h is Planck's constant. So we put our values in and we get our answer to be C. The next question says, what's the maximum possible wavelength of a photon emitted as the atom returns to the ground state? So pause the video now, then unpause the video when you want to go through your answer. Well, the answer for this one is going to be D, because lambda is equal to hc over E. So this tells us that the largest wavelength comes from the smallest possible energy level difference, because when E goes up, lambda goes down, and vice versa. So you find our smallest energy difference in EV, then multiply by 1.60 times 10 to the minus 19 to get our energy in joules, so our wavelength will be in meters, and we work it through to be 5.65 times 10 to the minus 6 meters. The next question says, a proton has a kinetic energy of 5 times 10 to the minus 12 joules. What is the de Broglie wavelength of the proton? So pause the video now, then unpause the video when you want to go through your answer. Right, so how do you answer this question? Well, the answer for this one is B, because you know that if we know that EK is a half mv squared, well then V is equal to the square root of 2 times by EK over m. So we'll just rearrange that particular equation. So we can pop our values in because we've got the mass of a proton, because it's given in the equation book, and we've been given the kinetic energy of our proton. That gives us a velocity of 7.7 times 10 to the 7 meters per second. We can then use the de Broglie wavelength equation, which is lambda equals h over mv, h being Planck's constant, and m being the mass of the proton, and v being the value you just worked out, to get our answer to be 5.13 times 10 to the minus 15 meters. The answer is B. The next question says, in a photoelectric experiment, light is incident on the metal surface of a photocell. Increasing the intensity of the illumination of the surface leads to an increase in the watt. So pause the video now, then unpause the video when you want to go through your answer. Well, the answer for this one is C, because when the intensity of the photons increases, there are more electrons released every second, and we know that how many electrons flow per second is the current, so therefore we know that our answer is going to be C. The next question says, monochromatic radiation from a source of light, source A, is shown on a metallic surface and electrons are emitted from the surface. When a second source, source B, is used, no electrons are emitted from a metallic surface. Which property of the radiation from source A must be greater than that of source B? So pause the video now, then unpause the video when you want to go through your answer. Well, we know that E is equal to HF, and so therefore the only factor that's going to affect E in a directly proportional manner is F. So therefore, if we need the radiation energy to be greater, well then only the frequency can be greater. So our answer is B. Let's have a look now at a few questions on force, energy and momentum. So the first question says, which row contains vector quantities only? So pause the video now, then unpause the video when you want to go through your answer. Right, so how do you answer this particular question? Well, the answer is B, because mass, energy, distance and speed are all scalars, whilst displacement, momentum and forces are all vectors. The next question says, which is a statement of Newton's third law of motion? So pause the video now, then unpause the video when you want to go through your answer. Well, you've got to be aware of what Newton's third law of motion is. It's just a fact you've got to learn. And that is, it's important that two objects interact and they exert equal yet opposite forces on each other where the force is the same type. So our answer is D. The next question says that when a ball is thrown into the air at an angle to the vertical, what is the correct statement? So pause the video now, then unpause the video when you want to go through your answer. Right, the answer here is B, because the vertical velocity of an object is instantaneously zero at the point it reaches its highest point, because it isn't going to travel any further than the highest point, so therefore it's no longer travelling upwards. So therefore our answer is B. The next question says, a conveyor belt raises 20 boxes, each of mass 60 kilograms, to a vertical height of 12 meters every 30 seconds. The conveyor belt operates at a steady speed. What is the useful output power of the conveyor belt? So pause the video now, then unpause the video when you want to go through your answer. Right, so the answer here is B, because you know power is work done over time. Well, work done is the force times by the distance moved in the direction of the force. So we can do 20 times by 60 times by 9.81, so turning our mass into a force into weight by times it by gravity, times by 12 because it's moving a height of 12 meters, and therefore we can divide it by 30 to get our power, which is 4.7 kilowatts. The next question says, this graph shows the variation of extension with force for 4 wires. Which 2 wires store the exact same elastic strain energy at their maximum extension? So pause the video now, then unpause the video when you want to go through your answer. Right, so for this particular question, we know that elastic potential energy is a half kx squared, so therefore we can say it's also a half Fx, or force extension. So P and S are the same as when force is doubled, extension is halved if you look at the values on the graph, so the 2 will cancel through to get the same answer. The answer is B. The next question is, a sample of steel in the form of a Y is subjected to an increase in load. Which of the following is the best description of the elastic limit of steel? So pause the video now, then unpause the video when you want to go through your answer. Right, the answer here is C, because the elastic limit by definition is the highest stress where the object does not become permanently deformed. That's just the definition, so the answer is C. The next question says, 2 metal specimens X and Y are stretched until they break. Y has a greater Young modulus, a greater ultimate tensile stress, and is less brittle than X. The stress strain curve for X is shown, which is the stress strain curve for Y. So pause the video now, then unpause the video when you want to go through your answer. Right, so in this particular question, Y has to have a steeper gradient because the gradient is the Young modulus, so it's got a greater Young modulus, so a higher gradient. Now Y will also have a higher peak because the peak of the graph is the ultimate tensile stress, and also Y has a greater inelastic behaviour because it's less brittle, and brittle objects don't show much inelastic behaviour. The answer is B. The next question says, which is the unit for stiffness? So pause the video now, then unpause the video when you want to go through your answer. Right, for this particular question, what actually is stiffness? Well, stiffness is the spring constant, so stiffness is force over extension. Now we know force is work done times by distance. Now we know we're going to have to include that because there's meters in there and there's joules in there. So therefore we know it's going to be joule meters, work done times by distance, divided by meters, extension. So therefore it's going to be Jm to the minus 2. So the answer is A. The next question is, material P has a higher Young modulus but a lower ultimate tensile stress than material Q. Which graph shows the correct stress strain graph for P and Q? So pause the video now, then unpause the video when you want to go through your answer. Right, so the answer here is C. Why is that? Well, P has a lower peak because it's got a lower UTS, and the UTS, the ultimate tensile stress, is in fact the peak of the graph, and P has a steeper gradient because the gradient is the Young modulus, so therefore because it's higher, the gradient is steeper. Let's now have a look at some questions on current electricity. So the first question states, which of the following is an SI unit for electromotive force? So pause the video now, then unpause the video when you want to go through your answer. Right, the answer here is going to be D, because the EMF is the work done per unit charge into the circuit. That's the definition you've got to learn. That is a voltage, and the SI derived unit of voltage is the volt. The next question says, the following circuit contains 2 resistors of equal resistance in a diode. What is the reading of the digital voltmeter? So pause the video now, then unpause the video when you want to go through your answer. Right, the answer here is C, because the diode is acting against current flow. So there's going to be no current flowing down that particular path. So if each resistor has the same resistance, each output will have the same resistance. So as potential difference is proportional to the resistance, they'll take an equal share of the EMF because it's a potential divider. So therefore there's 2 of them, so it's going to be 1.5 volts over each resistor, and our answer therefore is C, 1.5 volts. The next question says, a circuit consists of 3 identical 1.5 volt bulbs connected to 2 1.5 volt cells. The switch is closed. Which row describes the change in brightness of bulb Y and bulb Z? So pause the video now, then unpause the video when you want to go through your answer. Right, the answer here is C. Why is that? Well, when the switch is closed, X and Y are now going to be parallel with each other. So this means that X and Y outputs have a lower equivalent resistance than before, because when things are in parallel, the overall resistance is going to get lower. So the potential divider, the potential difference, is proportional to the resistance of the component. So when the resistance is lower, the potential difference is lower. So therefore Y and X will be dimmer than they were before. So if X and Y take less of the potential difference, Z will take more of the potential difference, because the total PD out must equal the total EMF in. So therefore if Y is taken less, Z must be taken more, so that means Z will be brighter. The answer is C. The next question says here, identical resistors are connected in 4 combinations, P, Q, R, S and Z, between terminals X and Y. What is the order of decreasing combined resistance between X and Y? So pause the video now, then unpause the video when you want to go through your answer. Right, so the answer here is A, because you've got to consider equivalent resistance increases in series, yet decreases in parallel. So R only contains a parallel configuration, so we'll have the lowest resistance. P contains a series configuration only, so we'll have the highest resistance. And S contains both, so we'll have more resistance than Q, which only has one resistor. The answer is A. A battery with internal resistance is connected to a parallel arrangement of 2 resistors and a switch as shown. Initially switch S is open. What happens to the voltmeter and ammeter readings when switch S is closed? So pause the video now, then unpause the video when you want to go through your answer. Right, so the answer here is A, because when S is closed, the resistors are now in parallel, so this decreases the equivalent resistance. So this means the value of R in the circuit is lower, so therefore the PD is going to be lower. This gives a lower potential difference value on the voltmeter. So in a series circuit, because as the overall resistance of the circuit decreases for the same EMF, the current must increase, so therefore you get a higher value on your ammeter. The next question says, a negative temperature coefficient thermistor is connected to a resistor and a cell as shown. The temperature of the thermistor increases. What are the changes in the ammeter reading and the voltmeter reading? So pause the video now, then unpause the video when you want to go through your answer. Right, so the answer here is C, because when the temperature increases, the resistance of the thermistor decreases. That's a fact. So this means the potential difference of the thermistor will decrease, because in a potential divider circuit, the potential difference of the object is directly proportional to its resistance. This means the voltmeter reading will go down, and therefore in the circuit, because the total resistance has decreased, because you said the resistance of the thermistor has decreased, with the same EMF supplied, the current will increase, so the value on the ammeter increases. The next question says, a superconductor has a critical temperature theta C. Which graph shows the variation of resistivity ρ with temperature T for this superconductor? So pause the video now, then unpause the video when you want to go through your answer. Right, the answer here is A, because in a superconductor below the critical temperature there's no resistivity. So at the critical temperature the resistivity drops. Above the critical temperature the material acts like a conductor, so you'd see here as the temperature increases the conductivity increases, which would link into the resistivity also increasing. The next question says, which network of resistors has the largest total resistance? So pause the video now, then unpause the video when you want to go through your answer. Right, for this one you can work out all the values. Remember where we have in parallel 1 over RT equals 1 over R1 plus 1 over R2 plus 1 over Rn, whilst in series you just add the 2. So when you look at A, it's 1 over RT equals 1 over a half plus 1 over a quarter, so it works out to be 1.3. Work out B, works out to be 1.5. C equals 0.4, but the total therefore is going to be 2.4 because there's 2 things in series there. Then in D, the parallel component is 0.5, so the total is 1.5. So our biggest value is C. The next question says, what is the unit for the potential difference? So pause the video now, then unpause the video when you want to go through your answer. Right, the answer here is C, because potential difference is work done over charge, so it's joules over coulomb, but charge is current times by time, so it's A times by S, amps times by seconds. So you say it's joules over amp seconds, so it's J, A to the minus 1, S to the minus 1, which is C. The next question says the components in circuits X and Y are identical. The cells have negligible internal resistance. What is the ratio of the power dissipated in circuit X over the power dissipated in circuit Y? So pause the video now, then unpause the video when you want to go through your answer. Right, we know that power is V squared over R, and V is the same for both circuits because it says the cells are identical. So therefore, we know that power is proportional to 1 over R because V squared is the same for both. So in circuit X, R is equal to 2R because there's two resistors in series, whilst in Y, it's R is equal to a half R because resistance decreases in parallel. So therefore, X has 4 times as much resistance, so therefore, from looking at the equation, P equals V squared over R, 4 times less power. The answer is A. The next question. The diagram shows a 12-volt battery connected to a resistor of resistance R. The voltmeter reads 10 volts when the switch is closed. What's the internal resistance of the battery? So pause the video now, then unpause the video when you want to go through your answer. Right, the answer here is going to be B, because the lost volts is the EMF minus the terminal PD, the PD in the circuit. So it's 12 volts minus 10 volts, because there's 10 volts in the circuit read by the voltmeter, but 12 volts coming from the battery. So our lost volts is 2 volts. So as the potential difference is directly proportional to resistance in this particular circuit, this means that the lost volts is 2 over 12, so it's 1/6 of the PD. So this means it must be contributing to 1/6 of the resistance of the total circuit. This means if the load resistance is R, well therefore the internal resistance is R over 5, as when combined 0.2 R is 1/6 of 1.2 R. So the answer therefore is B. The next question says, a student set up the circuit as shown. She varied the resistance of the circuit and the graph shows the results obtained. Which statement is true? So pause the video now, then unpause the video when you want to go through your answer. Right, the answer here is D, because there's an internal resistance as V varies with I. As the internal resistance increases, there's less energy transfer to the circuit, and then the current goes down. Now, the maximum energy transfer does not occur at 12 volts, as to achieve the EMF, there's got to be no circuit output, so there can't be an energy transfer. And finally, the internal resistance is equal to the negative gradient, which from the graph is minus 10 over 2, which is therefore going to be equal to 5 ohms. The next question says, a battery of negligible internal resistance may be connected between any 2 points P, Q, R and S of the network of resistors shown. Which connections will give the largest current and the smallest current in the battery? So pause the video now, then unpause the video when you want to go through your answer. Right, it's important to note that we've got to consider about the resistance. So the highest current gives the lowest resistance and vice versa. So what you would do is between P and Q, P and R and S and Q and S, work out your total resistance. So you can do that by either adding the resistors in series or just finding the value of the one resistor. Now again, the highest resistance is from the lowest current and vice versa. So the highest current is PQ because it has the lowest resistance, and the smallest current is QS because it has the highest resistance. The next question says, what is the unit of resistance when expressed in SI base units? So pause the video now, then unpause the video when you want to go through your answer. Right, the answer here is B, because resistance is PD over current, so it's V over A. Now we know potential difference, V, is work done over charge, and we know work done is force times by distance. Now we know force is mass times acceleration, so we can say mass times by acceleration times by distance over charge, all over the current, is equal to resistance, and we can turn charge into current times by time. So we then pop in all of our units there for mass, acceleration, distance, current, time, and current, time, and current again. Work it all through, cancel the values through, and you get your answer of B, kg m squared s to the minus 3 a to the minus 2. Right, the next question says, a battery of the electromotive force 6 volts and negligible internal resistance is connected to the resistors as shown. Each resistor has a resistance of 4 kilo ohms. What's the current in resistor X? So pause the video now, then unpause the video when you want to go through your answer. Right, the answer here will be B, because in the circuit we know I is equal to V over R. Now the total R in our circuit, because we've got a parallel component, is going to be 1 over RT, so it's 1 over 4000 plus 1 over 4000. That works out the resistance of the parallel component, then add it to the resistance of the resistor in series to get 6000 ohms. Now so therefore I is equal to 6, which is the EMF from the battery, over 6000, so we get 1 milliamp. Now when it reaches the junction between the two resistors in parallel, the current will split evenly because the resistance of each resistor is the same, so therefore the path have the same resistance, so therefore the current of path X will actually be half of the value beforehand, so it's going to be 1 milliamp over 2, 0.5 milliamps. The answer is B. The next question says the sum of the electrical currents into a point in a circuit is equal to the sum of the currents out of the point of the circuit. Which of the statements is correct? So pause the video now, then unpause the video when you want to go through your answer. Right, so we know that the answer is A, because Kirchhoff's first law is based on the conservation of charge, while Kirchhoff's second law is based on the conservation of energy. So the sum of current in a junction links to our conservation of charge, because current is the charge divided by the time. The next question says, which of the following graphs shows how current I varies with the potential difference V for a negative temperature coefficient thermistor? So pause the video now, then unpause the video when you want to go through your answer. The answer here is C, because for a negative temperature coefficient, the higher the temperature, the lower the resistance. So when the potential difference increases, the temperature increases, the resistance decreases. And a decrease in resistance is indicated by a steeper line on the IV graph, because I over V is 1 over resistance. So therefore our answer is C. Next question. In the circuit shown, the batteries have negligible internal resistance. What are the values of current I1, I2, I3? So pause the video now, then unpause the video when you want to go through your answers. Right, our answer here is going to be C, because consider Kirchhoff's first law. Total current in equals total current out. So therefore I2 is equal to I1 plus I3, because current going into the dot in the middle is I1 plus I3 and going out is I2. So therefore I1 will have the larger current because it's got the larger EMF supply compared to I3 by looking at the values. So therefore our answer is going to be C. Let's now have a look at a few questions on waves. So look at the following question. Graph 1 shows how the displacement of one particles of a medium varies with time in seconds as a wave travels through a medium. Graph 2 shows how the displacement varies with distance in meters at one time for the same wave. What expression gives the speed of the wave? So pause the video now, then unpause the video when you want to go through your answer. Right, the answer here is going to be T1 minus T2 tells us that there's 1.5 waves, and in x2 minus x1 there's 0.5 waves. So therefore in T2 minus T1 there's 3 x2 minus x1, so therefore speed is distance over time, so it's 3 distances over 1 time, so therefore the answer is E. The next question says two speakers S1 and S2 are placed 11 meters apart and connected to a signal generator, producing a sound of wavelength 2 meters. The sound waves emitted by S1 and S2 are in phase, and the point X is 5 meters from S1 and 6 meters from S2. Which of the following best describes the phase relationship between the sound waves received from the speakers at point X? So pause the video now, then unpause the video when you want to go through your answer. Right, the answer here is going to be C, because point X is different distances between S1 and S2. So you work out the ratios between the distances compared to the overall separation, and this implies that the waves arrive at a half wavelength difference, because 1 meter is when one's at 1 and 2 meters at the other at X, so that means they're in anti-phase. So they'll cancel out, and the answer is C. The next question says a light source emits light which is a mixture of two wavelengths, lambda 1 and lambda 2. When light is incident on a diffraction gradient, it's found that the fifth order of light of wavelength lambda 1 occurs at the same angle as the fourth order of light of wavelength lambda 2. If lambda 1 is 480 nanometers, what's lambda 2? So pause the video now, then unpause the video when you want to go through your answer. Right, we know that d sine theta equals n lambda, and for both cases d sine theta is the same number, so we can therefore say n lambda equals n lambda, and we know that beforehand it's 5 times by 480 times 10 to the minus 9, because we're working from nanometers into meters. We know the diffraction order afterwards is 4, so therefore it's 5 times by 480 times by 10 to the minus 9 equals 4 times by wavelengths. You work it through and you get the answer to be C. The next question says, sound waves cross a boundary between two media X and Y. The frequency of the waves in X is 400 Hz. The speed of the waves in X is 330 meters per second. The speed of the waves in Y is 1320 meters per second. What are the correct frequency in wavelengths in Y? So pause the video now, then unpause the video when you want to go through your answer. Well, you know from the question that speed equals frequency times by wavelength, and the speed must equal 1320 for Y. Now the only combination that does this is 400 Hz and 3.3 meters, so the answer is C. The next question says, a stationary wave produced by two loudspeakers emitting sound of the same frequency. When the microphone is moved between X and Y, a distance of 1.5 meters, 6 nodes and 7 antinodes are detected. What is the wavelength of the sound? So pause the video now, then unpause the video when you want to go through your answer. Right, when you look at the picture, you can see there are 3 whole wavelengths. This means that if the total wavelength is 1.50 meters, well therefore what we can do is we can divide our total length by 3 to get the wavelength of 1, so therefore our answer is 0.50. The answer is A. The next question says, light crosses boundary from air into a substance that has a refractive index of 2. What happens to the speed, frequency and wavelength of the light as it crosses the boundary? So pause the video now, then unpause the video when you want to go through your answer. Right, it's important to note that in refraction it's a fact that frequency always remains constant, but if the wave is going to a higher refractive index, then it must slow down by half because the refractive index is doubling, so therefore the wavelength must halve due to the wave speed equation, so therefore our answer is A. The next question says, light of wavelength 500 nanometers is incident on a double slit and the resultant fringe pattern is shown below. V is the central bright fringe and the dark fringes are shown shaded. What is the path difference that results in fringe W? So pause the video now, then unpause the video when you want to go through your answers. Right, the answer here is A, because W is a second order dark fringe, because it's the second one from the centre. This means that the two waves must be out of phase with each other to get this dark fringe, and so must have a path difference of an odd number of half wavelengths. The path difference is therefore 2.5 wavelengths, as the equation is 2n plus 1 divided by 2 wavelengths for your dark fringes, which gives us an answer of 1250 nanometers. The next question says, the diagram shows the cross-section of a progressive transverse wave travelling at 24 centimeters per second on water. The amplitude of the wave is 2 centimeters and the frequency is 4 Hz. What statement is correct? So pause the video now, then unpause the video when you want to go through your answer. Well, the answer is going to be A, because S is half a wavelength ahead of P. When you consider that P is repeated at further along the wave, and S will be a quarter of a wavelength away. Now that tells us that a quarter of a wavelength has a phase difference of pi over 2, so therefore our answer is going to be A. We'll now have a look at some questions on periodic motion. So look at the following graph, which shows the variation of displacement x with time t for an object performing simple harmonic motion. T is the period of oscillation. Which graph shows the variation of acceleration a with time t for the object? So pause the video now, then unpause the video when you want to go through your answer. Right, the answer here is C, because acceleration is directly proportional to displacement but in the negative direction. That's simple harmonic motion. This means that an acceleration time graph is a reflection of a displacement time graph in the x-axis. The answer is C. The next question has a graph showing the variation of velocity v with time t for an object performing simple harmonic motion. The period of oscillation is t, the maximum acceleration of the object is equivalent to what? So pause the video now, then unpause the video when you want to go through your answer. Right, so the answer here is A, because the gradient of a velocity time graph is the acceleration, so therefore the maximum value of acceleration is when the gradient is the steepest, which occurs when t equals 0, so our answer is A. The next question says, the total energy of an object that is performing simple harmonic motion is what? So pause the video now, then unpause the video when you want to go through your answer. Right, the answer here is D, because the total energy can never be 0, because there's never no potential energy for an energy store. The total energy is not a maximum speed, as the gravitational potential energy is a minimum. And then finally, the total energy is not a maximum in max displacement, as the kinetic energy is a minimum. So therefore our answer has to be D. The next question has, the graph shows a variation of displacement x with time t for an object performing simple harmonic motion. Point P has a displacement of 2 centimeters from equilibrium. What's the velocity of the object at point P? So pause the video now, then unpause the video when you want to go through your answer. Right, our answer here is C, because we use our equation v equals plus or minus omega or 2 pi f times by the square root of a squared minus x squared. So we know that 2 pi f is going to be 2 pi times by 1 over 0.8. We can work out what time period is from the graph because it's 0.8 seconds for one time period. We've got our value of x and of a. We can work it through to be 26.2 meters per second, or centimeters per second, I should say. The next question says, for a particle moving in a circle with uniform speed, which of the following statements is incorrect? So pause the video now, then unpause the video when you want to go through your answer. Right, the answer is going to be C, because displacement will always occur perpendicular to the force, because when you've got an object moving in a circle, it has a centripetal force. The force is always perpendicular to the velocity, because it is that centripetal force, and the kinetic energy is constant, as the magnitude of velocity never changes at uniform speed. So our answer is C. The next question says, a revolving mountaintop restaurant turns slowly, completing a full rotation in 50 minutes. A man sitting in the restaurant 50 meters from the axis of rotation. What is the speed of the man relative to a stationary point outside of the restaurant? So pause the video now, then unpause the video when you want to go through your answers. Right, so the answer here is going to be A, because we know that the angular velocity, omega, is equal to 2 pi over t, so therefore it's 2 pi over 50 times by 60, because we work in seconds, not minutes, so we get our answer with 2.09 times 10 to the minus 3 radians per second. We therefore know that V is equal to omega r, so we can multiply that by r, which is 15 meters, because that's the radius of the axis of the rotation circle, so therefore we get 3.14 times 10 to the minus 2 meters per second, which is going to be A. The next question says, a simple pendulum and a mass spring system are taken to the moon, where the gravitational field is less than the Earth. Which line A to D in the table correctly describes the change, if any, in the period when compared with its value on the Earth? So pause the video now, then unpause the video when you want to go through your answer. Right, the answer here is going to be A, because on the moon the gravitational field strength changes. Now this only affects the pendulum and not the mass spring, because you know T equals 2 pi square root m over k for the mass spring, so there's no g in that equation, but for pendulum it's 2 pi times by the square root of L over g, so it's in there. So this tells us that if we say 2 pi times by the square root of L over g is our equation, the lower the value of g, the longer the time period. As the restoring force is smaller as well, you can think of it like that. So therefore our answer is going to be A. The next question says, a ball of mass 0.2 kilograms moves in a horizontal circle of a radius 50 centimeters at the end of a string. The ball moves at a constant speed of 9 meters per second. What's the horizontal force exerted by the ball on the string? So pause the video now, then unpause the video when you want to go through your answer. Right, well our answer is going to be equal to C, because the centripetal force F is equal to mv squared over r. We've got m, we've got v, and we've got r in the question. But remember, we turned centimetres into metres, so we get 32.4 newtons. Now the string will pull the ball towards the centre, so therefore via Newton's law, the ball, so therefore it will pull, the horizontal force exerted on the ball by the string will pull away from the centre, so therefore our answer is C, because we've got to think of Newton's law here. It's going to be the third law, because there are two objects, the ball and the string. Our next question says, a body of mass m oscillates with simple harmonic motion on a spring of spring constant k. At one instance in the oscillation, the mass is distance y above the equilibrium position. Which row gives the magnitude and direction of the acceleration of the mass? So pause the video now, then unpause the video when you want to go through your answer. Right, so the answer here is B, because you know acceleration is equal to F over m, that's Newton's second law. Now we also know that in this case, because it's being stretched, it's going to be equal to kx, or k extension. That's what our force is equal to. So we can say acceleration is kx over m, because we know that from Hooke's law. So that tells us that acceleration always acts towards equilibrium, and then this is back down because currently it's above the equilibrium position as given in the question. So therefore we've got our magnitude of acceleration, and it must be directed downwards towards equilibrium. So hopefully you've been successful and you've learned in today's revision session. So you should be able to answer A-level physics examination style questions, assess your understanding on A-level physics, then understand what topics you need to improve upon for A-level physics. So thank you very much for watching this paper 1 revision session for AQA A-level physics. Thank you very much and have a lovely day.